Hi students, welcome to Future Dr. NEET Academy for the live session in YouTube for crash course in NEET Physics. Topic today we are going to discuss is from chapter 4, Moving Charges and Magnetism. In this, some of the topics we have discussed already in last session. Just we will revise or recall and then we will proceed next. Magnetism. Main application of magnetism is one of the very important fields in physics. That is, large electromagnets are used to pick up heavy loads. That is in electromagnetic lift. Magnets are used in such devices as meters, that is, as we discussed, meters in the sense galvanometer, ammeter, voltmeter, etc. All the meters use magnets or magnetism. Motors, electric motors, not only electric motors, also generator, electric generator or dynamo, that also uses magnets or magnetic field, and loudspeakers. Magnetic tapes and discs are used routinely in sound and video recording equipment and to store computer data. That is magnetic tapes, that is a video cassette recorder, audio cassette player, like that cassettes may be used in olden days. That is made up of magnetic tapes. Nowadays we are using disc. Disc in the sense compact disc as CD, DVD. The expansion of DVD, yesterday I asked this question. What is the expansion of DVD? Digital versatile disc. Or used routinely in sound and video recording, that is audio and video recording equipment, and to store computer data. As we discussed, and I asked one question here, that is CD. That is the storage capacity of CD is 700 MB. Is it so? Like that, I asked one question, that is, what is the storage capacity of DVD? How much? Have you found? Forgot. Okay, take one more day time. Try to find the answer for this question. That is, question is a yesterday question, that is, what is the storage capacity of normal DVD? DVD is different kind, double layer, single layer, like that. I am asking normal DVD, what we are commercially using. Okay, that is the storage capacity of CD is 700 MB, 700 megabytes. Same way, what is the storage capacity of DVD? Okay. And also to store computer data, not only DVD, hard disk, HDD, hard disk drive, that also uses magnetic fields only. And some more applications are there, that is intense magnetic field, highly intense magnetic field, or that is of the order of Tesla, kilo Tesla, mega Tesla, are used in MRI scanning, that is a magnetic resonance imaging devices to explore the human body with better resolution. That is, a whole body scanning can be done using MRI scanning, and it is greater safety than X-rays, because X-rays, suppose if you pass more amount of X-ray is somewhat harmful, and so it is better safety and good resolution also. Giant superconducting magnets are used in the cyclotron that guide particles into targets at nearly the speed of light. What is cyclotron? Cyclotron is a device used to accelerate the charged particle, that is a particle accelerator. That is, some of the particle, electron-like particle, whose velocity can be increased, accelerated nearer to speed of light. And magnetism is closely related with the electricity. Magnetic fields affect moving charges, and moving charges produce magnetic field. Changing magnetic field can even create electric fields. These phenomena signify an underlying unity of electricity and magnetism, which was first described by James Clerk Maxwell in the 19th century. The ultimate source of any magnetic field is electric current. Okay, let's move to first topic, Biot-Savart law. This already we discussed yesterday. Biot-Savart law states that is magnetic induction or magnetic field at a point for a element or wire carrying current I, and let P is a point. P is a point which is at r distance from the element, dl element. dl is the length of the element. Okay, and AB is equal to dl, and P is from center point. And what is theta? Theta is the angle between the direction of dl, and that is the angle between direction of dl and the point between the dl and P. That is only theta. And we discussed already dB is proportional to sine theta, and dB is proportional to magnitude of current I, and dB is proportional to dl, that is current element, length of the element, and dB is inversely proportional to square of the distance or cube of the distance. Take it. Yesterday we have discussed, yes, square of the distance, and by using the vector component, vector form only, multiply with r cap, and r cap equal to r vector by r, then only r vector by r cube. Yes, that is given here. See, dB equal to mu naught or simply mu ideal sin theta by 4 pi r square. Here theta is the angle between dl and r. And in vector notation, if you want to bring, multiplied by r cap, and r cap equal to r vector by r, that gives mu naught by 4 pi ideal cross r by r cube. Okay, so this is in vector form or vector notation. So, and from this also previous NEET question, one question will be asked in this. That is without introducing r cap, by the introducing of r cap, how is that dB value in terms of vector notation. So if you are thorough in these two formulas, you are able to answer. Okay. Let's move to next topic. Magnetic field around a straight conductor carrying current. Magnetic field at a distance or from straight long infinite wire carrying a current I, that is B equal to mu naught I by 2 pi r. R is a distance, and field lines are circles concentric with wire, and here this is a wire carrying current, and here this is a dotted line, that is a circle, concentric circle only indicates it is a magnetic field. As we discussed, whenever electric current is produced, there will be interrelated with magnetic field, that is only this. Next, magnetic field around a straight conductor carrying current. This is to find the direction of the current and also direction of the magnetic field. That is, how is it? Here, what is the direction of magnetic field? It's clockwise or anti-clockwise in A figure. It's a clockwise. Suppose the magnetic field is in clockwise direction, then current will be moving inwards of the paper, moving towards inside. And if it is anti-clockwise, then current will be acting outwards. So it gives the direction of magnetic field as well as direction of current. Same way, Maxwell right-handed corkscrew rule. That is, if a right-handed corkscrew is rotated to advance along the direction of current through a conductor, then the direction of rotation of the screw gives the direction of magnetic lines of force around the conductor. That is, your direction of magnetic field gives the direction of magnetic lines of force, and the screw moving inside, no, that indicates the direction of current. That is, how is the direction of current, and how is the direction of magnetic field, and how is the direction of magnetic lines of force. That will be given by right-handed corkscrew rule. Next topic, magnetic field due to circular coil. This also we have discussed, just we are recalling. And magnetic field due to a circular coil of radius capital R carrying a current I at an axial distance x from the center is B equal to mu naught I R square divided by 2 into x square plus R square whole power 3 by 2. What is mu naught? Mu naught is the permeability of a free space or vacuum. I is the current, magnitude of the current. R is the radius of the circular coil, and X, what is X? X is the distance between the point and the center of the coil. R, what is R? R is the radius of the circular coil, and if the point is at the center of the coil, then X equal to 0. The point is at the center, X equal to 0. Yesterday we have simplified this one. If X equal to 0, then 0 square 0, 0 plus R square whole power 3 by 2, R power 3. R square divided by R power 3, simplifying, we will get 1 by R. Therefore, B equal to mu naught I by 2R. This is the magnetic induction or magnetic field due to circular coil when the point is at the center, exact center of the coil. Next, direction of M is given by the right hand thumb rule. This is a right hand thumb rule. Curl and the palm of your right hand along the loop with the fingers pointing the direction of the current. Then the thumb sticking out gives the direction of M and A. This thumb only will give the direction of M and A. See here, that is I or QV is given by index finger, and thumb finger represents F, force. Next, magnetic field due to solid conductor, that is a long straight wire with circular cross section of radius A. And here it has two cases, when the point is present inside or outside. Suppose the magnetic field in a region R is less than A. Here what is A? A is the radius of the circular cross section of the wire. Okay, R is less than A. Then B equal to mu naught I by 2 pi A square R. Remember, in this formula many problems asked, and same way this graph also many times asked repeatedly. This graph is very, very important. Okay, and magnetic field in a region R is less than A. R is less than A means the point is present inside. Then B equal to mu naught I by 2 pi A square into R. What is R? R is a distance. Point at a, R is a point at a particular distance. A is a radius. And when a magnetic field in a region R is greater than or equal to A,